Okay, hopefully all is going well. Hopefully all is well. Now we're going to do section 9.2. And we are continuing on talking about functions and relations. We're going to use function notation, which we did a little bit in algebra. No, we didn't. I guess we haven't done it. I don't know if we've done it. And graph linear and constant functions. All right, so let's begin here. Notes to myself here. Okay. A function defined by an equation of this form, ax plus b, for real numbers a and b, is a linear, you knew that part already, function. All right. Blank f of x represents the value of the function at x, that is the y value. So function notation this is function notation, and we use it to represent the y value, right? So that's a different way of writing y. Instead of writing it as y, we're writing it in function notation. And this just means the y value at that particular x. Yeah. Okay. Next, fill in the blank. A blank, this would be constant, right? Constant linear function is in the form where y equals some number, right, b. And that's going to look like graphically y equals some set amount, a horizontal line. Ironically, we did horizontal lines in Algebra 1, I think it was today, just graphing them. Okay, moving on. Here is our function. I'm going to block it off in pink because it helps me visually. Evaluate it when x is 3. So they're saying take this function, figure out when you put a 3 in for x, what the y value is. Put a 3 for the x. F of 3 is 24 minus 7 is 17. So when x is 3, y is 17, right? F of 3 is the same thing as y. So f of 3 is 17. That's what you need right there. I'm just kind of specifying what it is that we just figured out. Okay, moving down. Here's a new function. Its name is g. And we're supposed to put in an a minus 1. Now, this is really starting to get us ready for pre-calculus and calculus, plugging in variables into equations with variables. So instead of g of x, I replace the x, this is what goes in place of the x, with an a minus 1. So over here, instead of the x, it's being replaced with a minus 1. Needs to be in parentheses because it's 4 times the x, and this is the whole x. So leave the left side just the way it is because that's a fancy name for y at a particular point. So distribute that. And then we get for a minus 11 is g at a minus 1. Okay, so when you put in a minus 1 for x, you get this as the corresponding y value there, which isn't that helpful, but it's helping us with notation that we're really going to need later. Okay, more with function notation for y. Okay. Find the function for this function, right here is the function f. Find f of negative 6. So this is really asking me, what is the y value when x is negative 6, right? So let's look here. There it would be. F at negative 6. The y value when x is negative 6 is 21. And this is the way they're going to want us to write that. F at negative 6, the y value at negative 6 is 21. Just a new notation, just takes some getting used to. I remember learning this and thinking it was tricky. many, many thousands of moons ago. Okay, let's look at this. Here's my function. Oh dear. Write the equation using function notation f of x. Then, okay, so we have two parts. So first I need to figure out f of x. That's another name for y. So first I'm going to solve this for y. 3y equals, subtract the 2x to over here. Divide everything by 3. I'm just going to write it like this. Negative 2/3 x, 7/3. You could have put the whole thing over 3. It's not wrong to do it that way. So another way you could have written this is negative 2x plus 7 over 3. That's absolutely fine also. Okay, either one. But they're saying, first of all, they want us to find f of x. So f of x is this one or that one. Just pick one. Right. Now that's the first one. Check. Now then find f at negative 3. Okay, so now I'm going to find f at negative 3. Okay, in that case, they're saying that this is going to be the x value. Figure out what the corresponding y is. So I have a negative 2. I'm putting in a negative 3. So it's negative 6 plus 7 is negative 1, no, positive 1/3. Is that, something looks weird. Positive 6 and 7 is 13. Ah, that's right, 13/3. So f of negative 3 is 13/3. Not the most satisfying answer we've had today. Okay. So what we're going to do now is divide these up. And since I have 3 visible non-6 students, we're going to divide them that way. So, Madeline, find f of negative 2. So take this equation and put negative 2 in for x. Joseph, find f of 0. And Matthew, find f of negative x. Also, Raven, do this one. Okay. Madeline, what is f of negative 2?
Negative 13.
It actually is. I don't mean to sound surprised. You usually get things right. And it sort of sounded like, oh, you're right this time. Wow, how about that? Okay. What about 0, Jonah? What did you get when you put 0 into that function?
Just a second.
Put a 0 for the x. So we're taking f of 0, which will be 3 times 0 minus 7. What do you get, Jonah?
He wrote the answer in the chat.
Oh, did he? Did he get it right?
Yeah.
Okay, I thought I heard him speak a second ago, then suddenly he became mute again. I know I heard him speak. Either that or I'm hearing voices. Did y'all hear them too? Yeah, that's good. Okay. All right. Matthew and Raven. Raven, you'll have to put yours in the chat. I'm going to open my chat back up. Raven, put what you got.
I got negative 10.
Nope. You're putting in an X. You have to have an X when it comes out, right? So I'm putting into this, instead of an X, a negative X. So instead of an x, a negative x. It's going to be a negative 3x minus 3. That was by far the hardest one. But if you put the negative x in, then the x doesn't go away, right? You just replace the x, looking right up here, replace the x with a negative x. Does that look good? Checking my answers from last time. Oh no, what did I do wrong? Speak up. It's not minus 3. The problem has a minus.
Is it negative 3x minus 7?
Yes, it should be a 7. I miscopied it there.
That's what I got.
Minus 7, minus 7, minus 7. I miscopied that number. I apologize. My eyes are really kind of blurry today. Okay. And I'm dyslexic. That's not a good combination. Okay, now we're going to do this one. And we're going to do it together. First, we're going to take this equation right here, and we're going to change all the x's to a negative 2. So I'm going to have f of negative 2. Where there's an x, I'm putting a negative 2. Where there's an x, I'm putting a negative 2. See a pattern emerging. Negative 2 squared is 4 times 2 is 8. Minus 2 minus 5 is minus 7 equals 1. So f at negative 2 is 1. So if we were putting this on a graph, there would be a point at x equals negative 2. The corresponding y would be at 1. That point would be on the graph. So we're finding these, yeah. Good. Now we're going to put a 0 in. F at 0. So when we're done, we're going to know the point is 0, comma something. And we're trying to find out the y value when the x is 0. So we go across the right side, and everywhere there's an x, we're replacing it with a 0. We get a negative 5. F at 0 is negative 5. So that would be another point on graphing this parabola when we were trying to graph it. That would be on the graph. And then finally, f of, now this is the hard one. They want us to put a negative x. So everywhere there's an x, change it to a negative x. It's getting squared. And then instead of an x, a negative x, and then a negative 5. So negative x times negative x, when I square it, becomes a positive. So that's just a 2x squared minus the x and minus the 5. So that is f of negative x. So it only changed slightly. It's the same with the 2x squared. That switched to a negative, and that stayed the same. So I would circle these like that, or put them in my answer blank. All right, the last one, f of x equals 9. This is a great one. First, figure out f of negative 2. What's your theory, someone? Madeline. 9 it is. Because this is telling us that y is 9, by God, nothing else, right? It's just 9. So if we put a negative 2 in, we get a 9. If we put a 0 in, we get a 9. If we put a negative x, we get a 9. Whatever we put in, we get a 9. This is a constant function that's like that, right? 9 units up. I like that one. That was easy. It doesn't happen very often, though. Okay, next page. Graph this function and give the range and the domain. Okay, first of all, to graph it, I hate fractions. So when I choose my numbers to put in, I'm going to put numbers that, oh, we'll get rid of my fractions. And at first I thought, well, I'll put a 2 there. It'll get rid of the fraction, but then I have to add a 1/2 to it, and that'll mess it back up, won't it? What if I put a 1? Then I would have 1/2 times 1. 1/2 plus 1/2 is 1. Oh, I like that. Let me try a -1. That'll be a -1/2 and a +1/2. And we only need 2 points to do a line. And this is a line because x is to the first, and that's a disguised old y. All right, that's a new name for y. That's the function notation for y. So I'm going to put this on my graph. 1, 1, and a -1, 0. I think I'm going to put 5 in there just because it would make me feel good. Yeah, sure. 5/2 plus 1 is 6/2. 6/2 is 3. 5, 3. I just wanted another point because those were kind of close together for my poor eyes. Okay. Remember, when we draw lines, we must go all the way across the graph. No wimpy lines. And we must put arrows on the ends. And we're supposed to tell the domain and the range. The domain is the x values. This goes on forever to the right and to the left, and that's the x values to the right and to the left. So the domain will be -infinity to infinity. And it's going up on this side and down on that side forever. So the y's are the range. So the y's will also go from -infinity to infinity. That's pretty good. I don't even think I put that last time when I was supposed to. I don't know. I've lost my place. I don't know where I am at all. I've completely lost my place. Let's see if I can find my place. Oh yeah, I found it. Okay, let's do the next one. I'm just kind of lazy. I don't want to have to divide by negative. I'm just going to add a y on both sides, get the y over here. And then I'm going to add a 2 to move the 2 off. So y equals 2x plus 2. You can solve it ever how you want, but that's what you should get. And this needs to be function notation, f of x. 2x plus 2. Why? I don't know. Graph each function. So there it is. All right, you don't have to do that. Make a table. All right, I'm going to let x be 0. 0 in there, I get a 2. I'm going to let x be -1 because I can tell that's going to be beautiful. Okay, that's fine. 0, 2, and -1, 0. And I know it's going to have a constant slope. Yep. Okay, grab your straight edge and draw yourself a line. Most lines have domains and ranges that are -infinity to +infinity. And this is one of those. It goes on to the right and to the left. So the domain is -infinity to infinity. And it goes up and down forever. So it's -infinity to infinity. Okay. All right. Moving on to the very next page. All right. Okay. So that is wanting to graph. And I'm going to solve it for y because I like it to be in slope intercept form. So I'm going to subtract off the 1/2 x. So I have y equals subtract off 1/2 x on this side. And oops, that's a minus. I don't know why I put a plus. Okay. Now I'm going to put some points into it. I think I'll put 0. And I want something that won't give me a fraction. So maybe I'll put, I think a -1 would be nice. I can tell that. Okay, so I'm going to put a 0 in there and I get a -2. Put a -1 times -1/2. Oops, I should put -2, sorry. Negative times negative is positive. 2 over 2 is 1. 1 minus 2 is -1. Oh, well, let's put those in the graph and see what it looks like. 0, -2, and -2, -1. I What happens if I put a -4 in there? Negative times negative is positive. 2 minus 2. Ah, that's 0. Perfect. It looked like it was going to be 0 just looking at my dots on the graph. So I just checked another point for the heck of it. Now, once again, I've lost my ruler. How do I do that? Okay, here we go. Almost always the domain of lines, negative infinity to infinity. This is no exception. Only when they're horizontal and vertical do we have something different. Okay. Negative infinity to infinity and negative infinity to infinity. The domain is the x values that are represented on the graph, and the range are the y values. Okay, so domain and range. The x's go on for infinity both directions. Same with the y's. Okay. This is more interesting. Y is 2. X can be anything your heart so desires, right? So pick a few things. All right. 0, 2. I picked 3, 2. This is a horizontal line. And it makes a more interesting domain and range. Oh, yes. Well, at least one of those is more interesting. The domain is another way for saying what x values are represented on the graph, and the range is what y values are represented on the graph. Okay, so on this graph, the x values go off to the right forever and left, and this is my x-axis, so I look this direction, negative infinity to infinity. Now the range. The range is, yeah, Matthew. I think you're muted.
2.
That's it. You just have to write it like this. We don't even put brackets or parentheses, and just 2. The y value, the only thing it is 2, which is really so easy. It's confusing, right? Yeah. The only thing the y value can be is 2. Yep, you got it. And this concludes this section. I did some practice notation. I'm going to do a couple more problems. I made up some extra things for practice, and I think we should probably do that with function notation because I know at least one of you was having a little trouble. So yeah. Okay, here we go. We're going to make up a few problems, and we're going to do some extra practice. We're going to call this example A, and f of x is x squared minus x, and I want you to find f of -3. You will definitely have 1 or 2 on your tests like this. So what I'm going to do here is I'm going to replace the x with a -3 every time there is an x. All the way across, folks. You have to be really careful to include the negative in there with it. It's positive. So the y value at x equals -3 is 12. That's how we write it. F of x is -3. Did y'all get that? Perfect. Let's do the next one. I have 4 or 5 of these. Okay, B. F of x is 2 minus x squared. I want you now to find f of -1. Okay, next one. If you're having any trouble with these, come back and watch the solutions. We're simply substituting, okay? F of x. This is really an important skill to have because you're going to use this in science classes and lots of higher math classes. Find f of 0. And this is one of those that should be easy, but sometimes messes people up. Put a 0 in everywhere there's an x. Moving right along. F of x is okay, it's a little harder when they have you put in a variable. And this time it's having you put a negative x everywhere there is an x. So your answer will have x's in them. In it. We're good? Letter E. F of x is 5 minus 3x. Find f of x plus 2. You need bigger challenge. So everywhere there's an x, you put the whole thing, x plus 2. Where you have an x, you're changing it to, this is going in place of x everywhere. We leave the left side alone each time. Notice that. So you should get this one or this one. Doesn't matter the order. Okay, I have another page with a couple more examples. So again, when you come to this video, you can go back through these and watch them again and check them and try them again. It's the beauty of these videos. I just love these videos, right? I don't watch them. That might drive me crazy. Okay, let's look at F as in fish. Okay. My daughter is allergic to every type of fish. Every single one. F of x plus 1. Okay, so replace all x's with this, x plus 1. And then work it out. This we have to FOIL. This symbol means like copy down, copy down. So at the very end, I put what I got. Did y'all get that? Remember to FOIL this first times first, outside 1x, inside 1x. That gives 2x in the middle there. Last times last, 1 times 1. We did first, outer, inner, last, the distributive property all the way through that. Okay. Just have a couple more. Well, 3 more, I think. G is f of x equals x squared. Find f of x plus h. And this is really something you're going to do in calculus as you start to learn with about limits, which means approaching things, right? Getting close, but not getting there. So in place of x, I put this. That's x plus h times x plus h. All right, so that's going to give me x squared plus xh plus xh plus h squared. Yes. 'Tis true, Raven, or whatever your name is at the moment. Oh dear, find G at 0. That means replace the X with 0. I have only one more. You might be sad to hear that. But it has two parts. It has part A and part B. So we'll call this part I1 because it's going to have two parts. F of X equals the absolute value of X plus 7. First, I want you to find F of negative 7. Those are absolute values, by the way. Get that? Perfect. And part B, part 2 on this, again, using F of X is equal to the absolute value of X plus 7. This time I want you to find F of 2. I should circle my answers everywhere. I don't think I circled them anywhere. Oh, well. Just annoy my grader, right? Oh, well, not to. Okay, we're good. Okay, we've got lots of practice with that, and you'll get more practice in your homework. And I'm going to stop recording and talk to you a second. Stop recording.